Hi, physics students. This is just a short video to go over balancing chemical equations. Alright, so on this first one, we're starting out with aluminum and O2, which is just two molecules of oxygen joined together with a chemical bond. So for our aluminum, we're going to use orange, and it looks like this. So we've got one atom of aluminum, and then for our O2 molecule, use blue, we have two oxygen atoms joined together to make O2. This is one thing, this is a separate thing. We're adding those together, and we're supposed to come up with aluminum oxide right here. Two aluminums connected with three oxygens makes aluminum oxide, which is basically rust. So that's how aluminum, I guess it is. I don't know. Alright, so we got aluminum, and there are two of those connected together. And then we have three oxygens on there. Alright, so we can see that this isn't balanced. We've got two oxygens here and three over here. We've got one aluminum and two aluminums. The first thing we can do is just add another aluminum. Now we have the right amount of aluminums, but we're still missing an oxygen. We can add two oxygens. We have to add two because they're joined together in a chemical bond. That takes care of one, but then we're left with an extra one. Alright, so what we're going to have to do is make a whole nother one of these molecules. So this is a full molecule right here at the end, aluminum oxide, and that's what it has to look like at the end. So we're going to add another aluminum. Actually, we're going to have to add two more aluminums, and then they'll join to this oxygen. And then we're going to have to add another O2. Gives us two more oxygens to join to this. And then it becomes a full molecule there with two aluminums and three oxygens. Okay, so each one of these is separate. We had four separate aluminums. And then we have three of these oxygen O2 molecules. So there are three of those, and there are four of those, and it equals two of these molecules. Now, if we look at this, we can see if it's balanced. So for aluminum, we have 1, 2, 3, 4. And over here, we have 1, 2, 3, 4 orange ones. So our aluminum equals 4 over here. That's balanced. For oxygen, we have 1, 2, 3, 4, 5, 6. 6 oxygen atoms in these three O2 molecules. And over here we have 1, 2, 3, 4, 5, 6. So our oxygen equals 6 oxygen atoms in those two aluminum oxide molecules. Alright, so to write the answer would be aluminum, we have 4. So we would write 4 Al for aluminum plus, then we're going to add 1, 2, 3 of these O2 molecules, 3 O2s, and that's going to equal 2 of these aluminum oxide molecules, so 2 aluminum oxides. And that's how you write the answer to that one. Alright, hopefully that was a little more understandable than our Zoom class. Let's try the next one. Is that the next one? No. See, I need to get to 2. There we go. Okay. Alright, so for this one, we're going to do the same thing. We're going to start off with carbon. And that's joined to an oxygen. And that we're adding hydrogen 2, H2. So that means 2 hydrogens joined together. Okay, and that's going to equal, then we have H2O, so 2 hydrogens joined together with an oxygen there. And then we have a CH4. So our C. And then we have 4 more hydrogen atoms. Okay, so that's what that's supposed to end up as. All right, we can see that this is definitely not balanced. Over here we've got 1 carbon, and over here we have 1 carbon, so our carbon's balanced out. Our hydrogen, over here we have 2. Over here we have 1, 2, 3, 4, 5, 6. And our oxygen, over here we have 1. And over here we have 1. Okay, so the one that's not balanced is going to be our hydrogen. So we got to try to balance this hydrogen. So if we added another hydrogen, that counts for 2 of them. Okay, so this would be 4. And if we added another hydrogen, that would make it be 6. Now we should be balanced. So I've got 1, 2, 3, 4, 5, 6. Okay, so this just splits apart. These 2 go onto here, and then these go onto there. Okay, here's our oxygen, and there's our carbon. Okay, so to write this, to write the answer, you're going to write, we've got 1 CO, so CO, plus 1, 2, 3 hydrogen 2s, so 3 H2, equals, we're going to end up with 1 molecule here and 1 molecule here. This is our H2O, our water, and this is our CH4. So we get 1 of each. H2O plus CH4. So that was a molecule. This is our CO. And each of these were a separate molecule. That's H2 and another H2 and 1 more H2. And we're all balanced out. And your answer should look like that. All right, let's try another one. And if you have to draw the little diagrams, like the diagrams really help me a bunch, especially using separate colors. Alright, so we're going to go hydrogen. No, this is Hg. Hg was mercury, pretty sure. Let me look it up. Mercury. Hg is mercury. Okay, so we have 1 of those. And then we've got an oxygen connected to that. And that makes our HgO. Wonder what that is. Let's find out. Mercuric oxide. Whatever that is. Okay. And then to that we're going to get another Hg by itself. And then we've got to get O2. which is 2 oxygens connected together. Alright, we can tell we're not balanced because over here we have 2 oxygens and over here we only have 1. So we're going to have to do a whole nother molecule with an oxygen connected. That gets our 2 oxygens, but we end up with an extra one of these HGs. Alright, now let's box each one. So this was our, whatever that was. Okay, and then we end up with a mercury by itself, another mercury by itself, and an oxygen, an O2. Alright, so we can check and make sure we're balanced. So our Hg equals 2 of them over here, and Hg equals 2 over here, so that's balanced. And over here our oxygen is 2, and over here our oxygen is 2. So we are balanced. And to write this, we're going to need 2 of these molecules, so 2 HGO plus, no, not plus anything, just equals. We didn't add anything to it. Equals, we're going to get 2 HGs plus 1 O2. Hopefully that made sense to everyone. That's how you write the answer. Alright, we're going to try another one. Alright, so this one is Ca. I like using blue for oxygen for some reason. We're going to go Ca as purple. What is Ca? Let's find out. Ca is calcium. Calcium, 1 calcium, and then we have 1 carbon, and we have 3 oxygens. Okay, and that's going to break down and create CaO. Wonder what that is. Let's find out. Calcium oxide. So 1 calcium oxide with an oxygen on it. And then 2 CO2s. Here's our oxygen. Here's our calcium. Here's our carbon with 2 oxygens on it. Alright, and now we can check and see if that's balanced. So we started off with this molecule right here. And we ended up with these 2 molecules right here when it broke down. And our calcium, we have 1. And over here, our calcium, we have 1. Our carbon, we have 2. No, we have 1. Whoopsie. We have 1 on this side, and our carbon on this side, we have 1. And then our oxygen, we have 3. And on this side, our oxygen, we have 3. So this is already balanced. So for this one, you just write so we don't have to do anything to that one. It's already balanced for us. Alright, let's try another one. Alright, so this one combines 2 things and comes up with 2 things. So we've got carbon, okay, by itself, plus Fe, which is iron. I'm going to use green for that. So here's my Fe2. So I have 2 Fe's stuck together, 2 irons, and then 3 oxygens. So 1, 2, 3 oxygens stuck on there. Okay, and we're trying to equal an iron, which is Fe, by itself, and then we're going to have a carbon, CO2, so carbon dioxide, and 2 oxygens. Okay, so we can see that that is not balanced. Let's see what's out of balance. So our C is 1, and on this side our C is 1. Our iron, over here we have 2. Over here we only have 1, so we're going to need some more iron. And our oxygen, over here we have 3. Over here we only have 2. Okay, so we're going to have to add some stuff to fix this. Okay, so what if we added a whole nother one of this Fe2? So let's box that so we can see what we've got. Alright, so that is a molecule, and then that guy's by itself. So if we added a whole nother one of those molecules, I think I wrote those too big. We're going to run out of room with 3 oxygens. Okay, so that would give us, alright, so right here, this one we have to write in. And then we had 1, 2, 3 in that top one, so we already had an extra oxygen. Alright, so now once we added this other molecule right here, okay, that gives us another 2 more Fe, and it gives us 3 more oxygens. So 1 there, and then 2 extras. Now all we need to do is add some more carbons to go with these oxygens. So 1 would go there, and then another one would go there. Alright, now I think we might be balanced. Alright, so let me box everything. So there's our carbons. We've got 3 carbons plus 2 of these molecules equals 3 of these Fe's by 4 of these Fe's by themselves. And then we get 3 of these CO2s. Okay, so this Fe by itself right here is this. Okay, and then the CO2 would be CO. Okay, that's over here, the C. And then the O would be the O2 right there. Each one of these has 2 oxygens. Alright, let's see if it's balanced. So for carbon, I've got 3 on this side. And I've got 3 on this side. And then for iron, I've got 4 on this side. And I've got 4 on that side. Whoops, that's supposed to be an E. And then for oxygen, I've got 1, 2, 3, 4, 5, 6 on this side. And then my oxygen on this side equals 1, 2, 1, 2, 3, 4, 5, 6. So now we're balanced. Alright, so how do we write this? Alright, so it's all this added together equals that. Okay, so we've got 3 carbons. plus 2 of these big molecules, right, the FeO3. I've got 2 of those here and here, okay? 1, 2, 2 Fe2O3, and that's going to equal what's on this side. So Fe1, we've got 1, 2, 3, 4 of those. That's iron. And then 1, 2, 3 CO2s. Alright, hopefully that made sense. That one's a little harder than the other ones. So we should have 3 carbons plus 2 Fe, iron 2, oxygen 3 equals 4 irons plus 3 CO2s. Yep. Alright, let's try another one. This is the last one I'm going to do here. Alright, so N2, wonder what N is. Doesn't matter. Okay, so we got 2 N's connected together. Okay, and they're connected together because that's a formula for something. Alright, and then we got 2 hydrogens connected together. Okay, and we're trying to come up with 1 N with 3 hydrogens. Okay, you can see this obviously not balanced. Okay, so the things on this side don't equal the things on that side of the arrow. Okay, so we got 2 hydrogens over here and 3 on that side. Alright, so what if we added... Alright, so this had 2 N's, so we've already got an extra N. But we're missing a hydrogen. Alright, so there's only 2 in that molecule. This had 2 N's. So we're going to have to make another hydrogen, H2 here. That'll give us this one that we were missing, plus 1 more. We're going to need 2 more. So if we added another hydrogen, that would give us 2 more. Okay, I think that balanced it. Let's double check. So on this side, our N is 2, and on this side we've got N, 2 purple ones. And then on this side, our H, hydrogen, is 1, 2, 3, 4, 5, 6, total of 6. And on this side, our H is 6. Alright, so that means that when we write this out, we're going to have the N2, we only have 1 of those. So N2 plus H2, we have 1, 2, 3 of those. 3 H2s. And we're going to get 2 of these NH3s. Oops. We need 2. Okay, so these break down and recombine to make these 2. Hopefully that made sense. Go back and try to work the rest of the problems. I just did 1 through 6, and there are 11 of them, so there's 5 more problems you can work. If you video yourself working those problems and explaining it to me, just pick, you'd only have to do 1 of them and explain it to me. I'll give you some extra credit. I'll drop your lowest test grade and give you 100 instead. Alright, hopefully that helped. And if you have questions, message me.